Hi, this is Richard White with an Introduction to Spreadsheets, Part 3. In Part 2, we looked at entering data into spreadsheet cells and formatting that data and the appearance of the cells. We also used editing commands like copy, cut, paste, and delete to move data around on the spreadsheet. Here, in Part 3, we're going to do calculations. Some people never use spreadsheets for anything more than formatting text or numbers into rows and columns, but that's not what spreadsheets were designed for. The real power of a spreadsheet becomes apparent when we set it up for calculations. This is some data from an experiment that I've been running. I've been rolling a ball down a ramp and measuring how much time it takes for the ball to reach various positions on the ramp, and I've entered that data into my spreadsheet. I've been running multiple trials of my time measurements for each distance, so I've entered that data into my spreadsheet here. Using editing commands covered in Part 2 of this series, I'm going to pretty up the data table a little bit. Not that that will make any difference to our calculations. It's important to keep in mind, though, that there are two parts to presenting information: the information itself and the presentation. Computers don't care about how the numbers look, but people do, and how successful you are in your communication is, for good or for bad, partly based on aesthetics like readability. So it's important to pay some attention to that. Here, I'm resizing the columns. I've made the headers for my data bold. I've indicated correct significant figures in my values. I'm centering some of the columns, outlining the data cells, and I've added a background color to the headers. Now, typically you'll want to have the value displayed in a cell based on the contents of other nearby cells. To indicate that you'd like the value in a cell to be a calculation, you click on that cell and enter an equals sign, followed by the formula or function that you want to have calculate the result. When you want the contents of a cell to be used in the formula, you can either type in the cell reference, A1, B2, etc., or you can simply click on the cell or range of cells that you want to be used. Here, I want to have the spreadsheet display an average for me, so I'm going to type in a column header here. The wrong way to calculate the average would be to do it myself on a calculator and enter that by hand here. Looking at the data in this row, I can already tell that the average of these three numbers is 0.29, but I'm not going to enter that here. A better way would be to have the spreadsheet calculated. Let me enter a calculation here. Equals cell B4 plus, I can also click on C4 plus D4 divided by, which is a slash sign, 3. This is how you calculate the average of three numbers. Add them up and divide by 3, and hit the Enter key. This is nice, but it's important to check our calculations and make sure that they're working correctly. Does this look like the correct average for these three numbers? The formula I've entered gets the wrong answer. I need to use parentheses to get the right order of operations so that I add the numbers before I divide by 3. When I click on the cell with the calculations in it, I can go up to the formula bar and then edit my calculation. I'll put the parentheses where they should be, and we can now see that our calculation is working correctly. The best way is even easier. Spreadsheets include functions that allow common operations like averaging a series of numbers to be done automatically. I still need to enter the equals sign first, but then I can insert function from the toolbar, or in some spreadsheets there's a toolbox that will help you find the function you need. The spreadsheet will sometimes try to fill in values for you, so you'll need to double check that the values you're trying to average are correctly indicated. Now, what if you have additional formulas to be entered, as I do here? We could hand enter the formula for each one of these, but a spreadsheet has tools that allow us to shortcut this process. Fill down and fill right allow us to extend a calculation from one cell into another. Once we have one calculation, we can select the cell that has that calculation, click dragging down or across to adjacent cells, and choosing Edit, Fill, and the direction we want to fill, in this case, down. You can see now that the same calculation pattern has been extended all the way down. If we click on any one of the calculations, we can see that formula there that is being used to calculate the value displayed. Notice that the spreadsheet is smart enough not to copy the actual formula that we used in the first row. It knows the pattern of our calculation, which is that we want to get the average of the three numbers to the left of this cell. Copying the formula copies this pattern intelligently. I should take a moment to explain that if you want to remove the information from these cells, you don't have to delete the cells. You could, but if you have other cells filled in on this sheet, they may get moved around. It's probably better to clear the information in these cells. You can clear the formatting of the cell only, leaving the data intact, or you can clear the contents of the cell, leaving the formatting intact. Here, I'm going to clear the contents of the cells so I can show you another technique for fill down. You can also fill down or fill right by clicking on the small box in the lower right corner of a calculation cell and using that to drag to adjacent cells. In part 3 here, we've looked at how spreadsheets can perform calculations for your data. This two-step process, having the spreadsheet perform a calculation and then automatically filling other cells with similar calculations, is the single most valuable thing that spreadsheets do. Perhaps the next most valuable thing that they can do is to create visual representations of data, charts and graphs. And that's what we'll do in our next unit.